Good evening, everyone. We will be starting the workshop in 2 minutes. Okay, so let's begin. Welcome everyone, and thank you very much for joining us. My name is Catherine Hall, and I am co-chair of the Central Asian Conservation Network. And it's with great pleasure that I welcome you to the first of our webinar series on bird conservation in the Central Asian Flyway. The Central Asian Conservation Network is a regional platform that aims to build coordinated conservation action in Central Asia and along the 30 countries of the Central Asian Flyway through transboundary collaboration. We currently count 25 organisations and over 50 experts as members, and we have 11 working groups that are active on topics ranging from species and family-specific conservation to data sharing, ringing and tagging, and conservation internships and volunteering. One of these working groups is the expert working group on green energy and conservation in the Central Asian Flyway. And I would like to thank the working group members who are presenting today, Dr. Todd Katzner, Geomini Panagoda, and Alyona Kaptionkina. A very big thank you also to the CACN Science Coordinator, Dr. Ramesh Kumar Selvaraj, for organising the webinar, and to my co-chair, Khurshid Alimov, for his support. The CACN is really quite a new platform, and we are very grateful for the enthusiasm and commitment of the members that has allowed it to grow so fast and so actively in recent months. We initiated the network late in 2024, very much inspired by the momentum generated by the Initiative for Central Asian Flyway that was adopted at the Convention on Migratory Species COP in Samarkand last year. Since then, we have hosted a regional conference in Bishkek in Kyrgyzstan. We've launched the 11 working groups and begun the development of a digital hub and database for the Central Asian Flyway. We are also currently preparing an application with IUCN Asia and the Hans Seidel Foundation to the Global Biodiversity Framework Fund for a regional project on conservation of migratory birds at key sites in the Flyway. I'll also just now briefly mention some upcoming events and activities, and we will be elaborating on these soon in the first edition of our newsletter. So as part of the development of the digital hub, we will be inviting all members to share details of their bird conservation projects in the CAF in order to build up a flyway level map of bird conservation. On the 1st of October, we will be hosting a workshop on nature, borders and migration with the University of Eastern Finland, exploring bird migration, society and mobility from an environmental policy perspective. And our next webinar in this series will take place on October the 10th in celebration of World Migratory Bird Day. So we very much hope to see you all there. We welcome all relevant conservation organisations, experts and conservation practitioners in or working with the countries of the Central Asian Flyway to apply and to join the CACN. If you think this could be relevant for you, please feel welcome to email myself and Khurshid for more information. I will put our email addresses in the chat. Last but not least, I would like to thank the Ornithological Society of the Middle East for their wonderful support, without which this webinar series would not be possible. So thank you all for joining, and without further ado, I will give the floor to the CACN Science Coordinator, Dr. Ramesh Kumar Selvaraj.
Thank you, Catherine. Thank you. Good evening, good afternoon, good morning, everyone. It's a pleasure to welcome you all once again to this webinar. As Catherine said, I am Ramesh, Science Coordinator of the CACN, and I also coordinate this particular working group of Green Energy Working Group of CACN. This working group is established to address the challenges in balancing migratory birds and rapidly developing renewable energy infrastructures in the Central Asian Flyway. Our purpose of this working group is to act as a regional technical platform that brings together researchers, conservationists, energy developers, and governments, to work together and minimize the impact of renewable energy on birds. It's a relatively new working group. We do have a strategic plan developed, and our main objective of this working group is to establish a centralized collision bird collision database for the Central Asian Flyway, because there are some database available. There is no centralized bird collision database available for the CAF. So one of our main objective is to develop this database and also to conduct targeted research in key collision hotspots and data deficient regions. In general, the whole of CAF, there are very few studies on this issue when compared to the Western countries and US. So we are trying to address that gap also. And other objective is to promote the mitigation measures and best practices in the CAF region, and also to strengthen the engagement with the governments, donors, and ensuring bird sensitive planning is embedded in the future energy infrastructure development. So our immediate next steps include the rolling out of more outreach programs like this webinar, and building a research directory on this issue, and as I said, developing a pollution database, and also initiating some joint projects to address these critical gaps with our partner organization. So with this, let us move on to today's webinar. Today's webinar's idea is to provide an overview of the impact of renewable energy on birds and also on the other wildlife, including bats, followed by two case studies from the CAF region. I hope you will enjoy the session. Please feel free to introduce yourself in the chat box, and also if you have any questions to the speakers, please type it in the chat box. It's now my pleasure to introduce our first speaker, Dr. Todd Kurtzner. Dr. Todd is a research wildlife biologist at Snake River Field Station of US Geological Survey in Boise, Idaho. He has over 35 years of experience in fields of ecology and conservation biology, and his recent work focuses on understanding and mitigating anthropogenic threats such as wind energy, toxicants, and illegal take for wildlife in North America and also globally. Kurtzner has an international research program focusing on raptors in Central Asia. He has over 200 peer-reviewed scientific publication, and he is co-editor and author of the book The Eagle Watchers. He received his PhD from Arizona State University for work focused on ecology and conservation of eagles in the Republic of Kazakhstan. Kurtzner was also co-founder of wildlife telemetry company Cellular Tracking Technology. Dr. Kurtzner, over to you.
Thanks very much, Ramesh and Catherine. This is really an honor to be able to speak here and to see all of you. You can hear me okay? Is that correct? Okay, let me make sure that, let me do my sharing thing. And so everyone, you can see the slides now as well, for the first slide. Is that correct?
We can, yes, thank you.
Perfect. And so if you have questions, please type them in the chat. And then I think after all three of the presentations, we will have a Q&A. So I want to speak to you today. I was asked to speak to you today about wind energy and biodiversity. And what I want to do is give a very broad overview talk that sets the stage for some of what is going to follow and what is happening in the world around us. This talk is based on is linked to a peer-reviewed paper that is going to be coming out in the coming weeks in the journal Nature Reviews Biodiversity. And we can make that available. It's going to be open access, I think. And it should be, if it's not open access, I can share a PDF with everybody on this call if you want. So the title of the talk and the title of the paper associated with it is Impacts of Onshore Wind Energy Production on Biodiversity. I have a group of co-authors literally from all over the world, many different countries, and that makes it a considerably stronger paper, I think. What we want to do is review the consequences for terrestrial of terrestrial wind turbines for biodiversity. And my goal in doing this is for those of you in the Central Asia region to set the stage for effective monitoring and mitigation and really management of wind energy, and also to introduce myself as a potential partner and resource for people in Central Asia. As Ramesh noted, I did my PhD in work. I did the field work in Kazakhstan, and I've been working in the region for more than 25 years at this time. So just by way of background, we know that wind energy is expanding rapidly all over the world. It's seen as a way to mitigate emissions of carbon dioxide and potentially to reduce climate change. But there's a paradox with this in that wind energy can kill wildlife, it can affect habitat, and so it can alter ecology and ecological processes. So what I'm going to do today is sort of divide this talk into three parts. I'm going to first talk about the growth of onshore wind power, and this image captures the growth of renewable energy. Wind is just one part of it, but it's an important part. And then after I've talked about the history and growth of wind power, then I'll talk about the impacts to biodiversity, different types of impacts. And then I will talk some about options for mitigation and some future next steps for understanding these impacts. So windmills have been around since at least the 12th century, and they were not initially used for generation of electricity. That didn't really happen until about the 19th century. In Altamont, California, in the US, was the site of the first really large-scale wind energy facility anywhere in the world. But it was also the site of the first real concerns about the impact of wind turbines on wildlife. We've gone from that first wind facility in California to a much bigger installed capacity all over the world. About 50% of the installed capacity is in Asia. As I'll show you in the next slide, most of that installed capacity is actually in China. Other parts of the world where there's a lot of wind energy production are in Europe, with about 22% of the installed capacity. In North America with just under 20%. So this figure really gives a nice overview of the of some different aspects of wind energy. You can see in the upper left, the installed capacity is greatest in Asia, followed by Europe and North America, and really least in Africa, South America, and even Australia, although it's growing quickly in several of those places. Prospective or planned capacity is greatest in Asia, again, primarily dominated by China. If you go back to pre-2000, so you look back at history, capacity was greatest primarily in Europe. And then recent growth has been primarily in North America, although that is changing rapidly with the present presidential administration. So when we think about the impacts of wind energy on biodiversity, we need to remember that this is a multi-phase process. So there's a planning phase before any wind energy is built. There's manufacturing, where we build the components. There's construction, where we actually install the wind turbines. And then there's operation, where these wind turbines are used to generate electricity. And then there's decommissioning, when these turbines are taken apart and broken down. The vast majority of the information we have about the impacts of wind energy on biodiversity are focused on the operational phase. That operational phase tends to be the longest. The impacts are the most visible, but it's really important to keep in mind that this process does have 4 other phases, all of which can have impacts on biodiversity. I'm not going to talk much about those because we just have no information on them, but it is something that's really important to keep in mind. There's also 4 main categories of impacts to biodiversity. Wind turbines can alter the habitat for wildlife or for vegetation. They can alter weather, which is really just a special case of habitat, but it's important and it's sort of distinct. They can alter the behavior of wildlife, and they can affect wildlife by causing fatalities. And all of these are important to consider, and I will discuss all of these today briefly. So there are impacts to biodiversity from changes to habitat. Habitat can be lost, it can be altered, it can be fragmented. And the way this happens is because wind turbines require roads, they require paths, the places where the turbines are placed, and they require infrastructure. You can see some of that in this image, and I think you can see my mouse. These are wind turbines, and this is the shadow of the wind turbine. The wind turbine is right here. There's a pad around the wind turbine, and there's a road connecting it. Wind turbines can also alter habitat by producing noise pollution, shadow flicker, sort of light pollution. Wind turbines can create wake effects. They change the weather, they change the habitat behind the wind turbine, which can result in changes to soil moisture and vegetation greenness. And when you're thinking about losses in habitat, it's really important to remember that habitat is a 3D concept. And so if you're a flying bird or a flying bat, if there's suddenly a wind turbine, then you have lost some of your habitat. And that's really important. We don't do a good job of measuring that, but it does have a really big impact on birds and bats. We also know that habitat loss is the greatest driver of global threats to biodiversity. And we know that turbines are often installed in pristine areas. So this is something that is really important to wildlife and to biodiversity. We know that wind turbines can affect weather as well. And again, this is a special case of habitat alteration, but it is really, really special. The presence of wind turbines can reduce local wind velocity. They can influence local turbulence, wind flow. They can influence precipitation. They can influence temperature. And all of that changes the reflectance of the ground, the albedo, can change the humidity, it can change the soil moisture, and it can change the temperature. And then there are consequences, as I noted before, for vegetation greenness and density. And that's all downwind from these wind turbines. We don't think about these effects on weather, but they can be really important. We also know that wind turbines can affect behavior of wildlife. So there are two main categories of behavioral change that are people have focused on. One is avoidance and one is attraction. So with regard to avoidance or displacement, we know that bats and raptors and grouse and ungulates and other mammalian predators can all avoid wind turbines. They can all change their behavior. If you look at this picture on the right, this is a track of an eagle, a golden eagle, flying near some wind turbines, I believe in Pennsylvania in the USA. And you can see this bird appears to change its behavior and then go between a gap in the wind turbines. We don't know exactly what this bird was thinking, but it does appear that it was responding to these wind turbines and changing its flight behavior. On the other hand, some species appear to be attracted to wind turbines. There's been some good literature suggesting that bats are actually attracted to wind turbines, and there's some evidence that mammalian and avian scavengers are also attracted to wind turbines. All of this is fundamentally a behavioral response to habitat alteration. And that's something important to keep in mind as we think about that. The other side of the impacts to biodiversity from fatalities, impacts to biodiversity are fatalities. And this is a picture of a red-tailed hawk at a wind facility or a dead red-tailed hawk at a wind facility in California. When we talk about flying wildlife, far and away the most numerous species taxa that are killed, vertebrate taxa that are killed, are bats. More bats are killed than any other species, and this is true everywhere where it's been studied, in North America and in Europe. And I would encourage you, as I've mentioned to others, when you're thinking about monitoring at wind facilities, make sure you are monitoring for birds, but also make sure you are monitoring for bats. Both of them are very, very important. Bats are the most numerous vertebrate that are killed. Raptors are the most conspicuous. They're really big. People are attracted to them. They're very visible. Raptors are heavily impacted by wind turbines. Probably the taxa that are killed in the greatest numbers are insects. And we don't think about insects much, but it is really important because they're food for birds, they're food for bats. They have really important roles as pollinators and things like that. Insects are very important to us, and their populations are certainly being affected by wind turbines. The cause of death of all of these fatalities typically is almost always collision. Typically, the collision is with the wind turbine blades. Some species collide with that tower, the big white pole. Grouse and pheasants and things like that are especially famous for colliding with towers. So the other side of these fatalities, though, I mentioned these individual fatalities, but when you kill many individuals, you can start to have population level and cumulative effects of these fatalities. We don't understand these well at all. We have a very poor knowledge of population and cumulative effects. But we do know that many hundreds of thousands, even millions of birds and bats are killed every year at wind turbines. And we know certainly for some species, there is evidence of population level effects. So there has been demonstrated population level effects for hoary bats and noctule bats, hoary bats in North America, noctule bats in Europe, and then lesser kestrels, black harriers, lesser kestrels in Europe, black harriers in Africa, golden eagles in North America, and Egyptian vultures in Europe. So for some species, we know there are population level effects, even though this isn't well studied. Understanding these effects, these population level effects, can be really difficult, and it often depends on things like the regulatory environment, what laws are there to require searching and to protect species, but also it depends on the type of searcher. If you have humans searching for dead animals, you never find many bats and you don't find many small birds. You find the big raptors, but you don't find the small things. But we have used dogs in conjunction with humans, and this is a dog with a person, again, in California. And when you use dogs, you start to find many, many bats that have been killed, and you find many, many small birds. So if you want to do good surveys for wildlife, it's really important to find ways to use dogs in your surveys. They make the surveys much better. So those are the population, the effects to biodiversity. The other side of this is that we want to mitigate those effects. And we do that, we use something called the mitigation hierarchy when we mitigate. So the mitigation hierarchy, the first thing you do is you try to avoid impacts to biodiversity. If you can't avoid these impacts, then you try to minimize these impacts. You try to make those impacts as small as possible. And then if you can't minimize effectively, then you need to compensate or replace. So if you kill a golden eagle, you need to produce another golden eagle somehow. And that way you offset or replace, compensate for animals that are killed. I'm going to talk about mitigation for a bit, but there's a couple of things to understand before I do that. First of all, most mitigation is for flying wildlife. There's been very little mitigation for habitat, for vegetative communities, for invertebrates, or for terrestrial wildlife. Almost all the mitigation is focused on flying wildlife. That's okay. It's a good place to start, but it can't be the last thing that we do. Mitigation also, again, depends heavily on the regulatory environment. Mitigation only occurs when there are laws requiring it or regulations or something like that. And that varies dramatically by country, by region. All these different things control the regulations. So I said there were 3 steps in the mitigation hierarchy. The first one is avoidance. This is the most important one because if you can avoid conflict with biodiversity, then you solve the problem. and you solve the problem even before the wind turbines are built. However, avoidance can also be really, really difficult because it depends on effective risk assessment. It depends on our ability to go to a site and say, there will be a problem with this species. And we are really, really bad at that. All of us are scientists or managers, and we need to recognize we do a very bad job of anticipating these impacts. We need to get better at that. All that said, avoidance is good for industry because it's the most cost-effective way to do this. If you can put your wind turbine in a place that produces just as much energy but has less risk to wildlife, it's a win for everybody and it costs you almost no money. The image on the right is just some modeling that my team and I did where we proposed moving the wind turbines in black to other places where there would be less risk from those turbines. This was a risk model we did for golden eagles, but it could be applied to any species. Avoidance can happen at a very large scale. It can happen when we're talking about broad geographic areas, and usually we're thinking about things like migration pathways for birds or key important bird areas, priority habitats. We can avoid at a very large scale, but we can also avoid at a very small scale within individual facilities. And that's what this image is showing on the right, just moving individual turbines so that you don't cost much in power production, but you reduce the risk to key species. If avoidance doesn't work, then you can engage in minimization. Minimization has traditionally been focused on birds and bats, but there are challenges. Minimization means reducing the number of animals you kill, and that depends often on the perception and the response of the species involved. So you do something to alert these species to the presence of a wind turbine, you deter them, and then they avoid the turbine on their own. We don't always know, though, what an animal's going to respond to. We don't know, for example, what a hoary bat or a nocturnal bat might see and how it might respond to a wind turbine. And that makes it really difficult to minimize. There have been some approaches that have been tested. So I'm part of a project that's shown in this picture where we are painting one of the blades of a wind turbine black, and we are trying to see if that has consequences for reducing the number of birds and eagles and even bats that are killed. This has been studied a little bit in Europe. Some studies have said it works. Some studies have said it doesn't work. People have also tried ultraviolet light. We think that probably doesn't have much effect on fatality rates. And then people have tried to implement acoustic deterrents, so things that scare animals away using noise. Early results are promising for this, both for birds and bats. There's probably some unintended consequence of it as well. If you want to implement a deterrent like that, then you need to detect the animal first, right? And so we need to find some way to say, hey, there's an eagle or a bat that is coming to the wind turbine. We need to implement our deterrent. Originally, detection has been done with humans. More recently, it's been done with cameras or acoustics, sound recordings, or radar. Typically, when this is done, you have sensors that cover multiple turbines. It often involves computer vision and machine learning. Detecting animals requires that we can detect them at a useful range, far enough away that we can respond, that we can say which species it is and what behavior it's engaged in, so we know the risk. And it requires that this information is provided in a way that is useful. This is a radar unit on the right that's deployed by one of my USGS colleagues, sometimes at wind facilities. So if the other thing we can do to minimize fatalities is to curtail, to stop the rotation of the wind turbine blades. This is done in many different countries. This can be conditioned two ways. It can be condition dependent, where under certain seasons, times of day, temperatures, or wind speeds, you stop the rotation of the wind turbine blades. It's been used effectively for bats, and it's one of the best ways to minimize fatalities of bats. It's been used less for birds. You can also do condition-dependent curtailment on demand. So when there is a bird or a bat present, you can stop the wind turbine blades from rotating. It's primarily been used for large birds and bats, and it's been used with humans or AI systems to reduce the risk. The biggest problem with this, especially with the AI systems, is that the number of false positives can be high. Finally, there is compensation to offset or replace, and this is only after avoidance and mitigation have failed. You can target compensation at demography or habitat. You can protect habitat or species or prey. So you can protect the roosts of a bat, wetlands for waterfowl. The other thing you can do is enhance numbers of wildlife. You can do feeding of animals or captive breeding and release, or you can reduce threats. In the US, we do a lot of retrofitting of power poles so that there are fewer electrocutions. We also mitigate the threat from lead poisoning by giving people non-lead ammunition, and that's what this image shows on the right. Compensation has been critiqued because it's a little arbitrary. It's the last thing that you do, and so nobody wants to get to the point where you have to compensate, but it is useful if you get there. So Ramesh and Catherine, I am almost done here. I know I'm approaching the end of my time. I've got 3 or 4 minutes, I think, and I should finish just about on time. A key assumption to all of this, we assume that the costs to biodiversity from climate change will be greater than the costs from renewable energy. We assume that more bats, more eagles, more birds will die from climate change than they will from renewable energy. And some of the big environmental NGOs state this as fact. It's not fact. We don't know that this is true. We know that climate change will have bad consequences for wildlife, but it's also possible that renewable energy could have bad consequences, and we haven't evaluated these trade-offs. We can do this with net impact assessment, with scenario-based modeling, and things like that. There's lots of uncertainty in this, but there's also really good examples of how people have done this in other fields. Other key knowledge gaps are how will regulation and policy impact growth? We just don't know how much wind energy is coming. We don't know the full life cycle impacts of turbines on biodiversity. We don't know the demography of key species. We don't know the best ways to mitigate. And we just don't know how much wind there's going to be. Again, moving forward, some of the things that we as researchers and managers can do are to do research focused on the full life cycle impacts of wind turbines. We can do work focused on the demography of some of these key wildlife and plant species. And we can do scenario-based modeling to show that the impacts of climate change are or are not going to be greater than the impacts of wind turbines for these wildlife. So this is just about my last slide. I have one more final slide, but one of my goals is just to introduce me and to all of you and to introduce USGS as a resource. USGS is where I work, the US Geological Survey. We are often recognized as experts in renewable energy. We work closely with industry, managers, NGOs. And one of the reasons we can do this is that we are seen as an impartial scientific organization. And we have these fundamental scientific principles that make us impartial. So with that, we have this paper that is coming out very soon. I can make it available to everybody here. It will summarize all of this. And please, if you have questions or thoughts, feel free to shoot me an email. My email is on the screen, and Catherine and Ramesh also have it. So thank you very much for your time and attention. And I think I can stop sharing and hand the stage back over.
Thank you, Dr. Todd. It's a wonderful presentation. To be frank, I have done my PhD on the impact of wind energy on birds, but this is one of the clear talk I have heard during this entire period on clearly pointing out what are the impacts and what are the mitigations possible. It was wonderful. Thank you very much, Krishna. Please, if you have any questions, you can type it in the chat box. Once the other presentations are over, we can take the questions. So let's move on to our next speaker, Ms. Gayomini Panagoda. Gayomini is a PhD scholar at the University of Colombo, Sri Lanka. Along with her PhD supervisor, Dr. Sambat, she leads the research program on migration and movement patterns of waterbirds in northern Sri Lanka. She also coordinates the National Bird Rigging Program in Mannar, Sri Lanka, and Waterbird Tracking Project, which has produced new insight into long-distance migrations and connectivity of gulls and a couple of other water birds. Her research also examines the cumulative impacts of large-scale wind energy development on the waterbird populations in Mannar, which has been recently it has sparked a lot of political controversies, and thanks to Gayomini and Sambat, who have worked extensively to to stop those wind turbines on the bird habitat. Probably Gayomini will talk more on that. Gayomini, over to you, Gayomini.
Thank you very much, Dr. Ramesh. I hope my screen is visible and I'm audible enough for everybody.
Yes.
All good, right. So first of all, I'd like to thank Dr. Ramesh for having me for this giving me a session in this important talk to present my work and highlight the crisis, the wind energy crisis we have in Sri Lanka, and how we are navigating while also navigating forward, while also conserving and protecting our water birds and their habitats. So the topic for the day for me is conserving migratory birds in Mannar, Sri Lanka, and what are the challenges that we face from the renewable projects therein, not just in Mannar, but in the broader Park Bay Gulf of Mannar region. So today, in my talk, I'd like to bring your attention into a new tool that we have used to assess the cumulative effects of wind energy on wetland connectivity and population connectivity of water birds. So before me moving on, the part one of my presentation, my slide is not moving. Yeah, just wanted to show you my team. It's not just me. I'm a part of a really big project, Mannar Migration Monitoring Project. It's actually,
yes.
Yeah?
Yes. It was not moving, but
are my slides moving? Okay, yeah, cool. Right. So my work is supervised by Professor Sampath Seneviratne and Professor Kotagam, and we have Dr. Tej here, one of my co-supervisors, and Dr. Bala. And we also collaborate with the Chinese Academy of Sciences, specifically Professor Charlie. So we have built this waterbird Central Asian Flyway Sri Lanka waterbird tracking project, which is in operation which we launched in 2020, and it has been up and running for the last 5 years. So which had helped us a lot in understanding the migration systems and how MANA contributes to the broader Central Asian flyway to its waterbird migration and so on. And this is what you see here is Sri Lanka's crucial position in the Central Asian flyway. We are one of the southernmost land masses. And we know that we have 3 main regions where migratory birds used to enter into Sri Lanka: the northern area, the northeast, and also the western coast of the country. And out of these 3 main regions where the migratory birds come to Sri Lanka, Mannar Island can be identified as a crucial entry point because due to its close proximity to the Indian mainland and also the position of the Ramas Bridge or the Adams Bridge island chain connecting Indian peninsula to Sri Lanka, which acts as a series of stepping stones for the birds to hop from India to Sri Lanka. So Mannar is also one of the 4 waterbird richest regions in Sri Lanka in terms of diversity and density. So this is how Mannar would look like. In the winter, we have about 122 waterbird species overwintering there annually. That can go up to like 400,000 to 1 million waterbirds annually in the Mannar Island alone. And this is just I wanted to give you an idea about the extent of and the connectivity of Sri Lanka and Mannar within the broader Central Asian flyway. We have our tagged birds traveling as far as the northern Eurasia, the Arctic Ocean, and we have birds traveling through 11 countries of the Central Asian flyway. So, taking you into a more zoomed in version of this migratory map, of this movement map. So this is what you're looking at here is the Pork Bay Gulf of Mannar region. So this is a really critical region, very ecologically important and also politically sensitive area. So we have this region actually bordered with a lot of Ramsar sites and important bird areas in both sides on Indian and Sri Lankan side. Here, in this map, I try to highlight. Now we have tagged waterbirds in Mannar. Actually, this map comes from 25 successfully tracked individuals that belongs to a dozen of waterbird species. And this map shows how these birds that were tagged in Mannar use this entire Pork Bay Gulf of Mannar region while they were overwintering, or for some species who oversummered. So this does not include any migratory bouts, but just their local movements while they spend the non-breeding season in Sri Lanka. So you can see that. So in a particular season, the birds that we see in Mannar normally, they just don't stay in Mannar throughout the whole winter. They would travel along the northwestern coastal belt of Sri Lanka. They would go to Jaffna, they would go to Point Kalima, to Dhanushkodi, Ramas Bridge, and comes back to Mannar and even go further south along the Gulf of Mannar to Putlam area of Sri Lanka. So based on, so actually we wanted to look deeper into the home and core ranges of these tagged birds and species. And so we have calculated their home and core ranges and showing here some of those maps that we created to show the scale of movement of some of the birds that we have tagged. This map shows two globally near threatened species and a threatened species, the bar-tailed godwit and the great knot. And this map shows their home ranges extend further north, all the way to the Pork Bay, to the Point Kalima. Like species like crab plover had very intricate movement patterns that spread across the entire Pork Bay. And based on this, there are home ranges and core ranges that we studied, that we assessed using their tracking data. We identified 6 movement corridors that are intensively used by the waterbirds that we tagged in Mannar, as listed here. So likewise, I just wanted to set up the stage for the talk today. So this is so we are moving on to the next part of my presentation, and we can see before moving on, I'd like to stress the fact that now we know that how the amount of traffic in the airspace in this region. So we bring the wind energy or the onshore wind energy projects into this picture. Now, this map that I present right here shows the onshore wind energy potential in Sri Lanka. So the whole northwestern coastal belt, starting from Putlam Peninsula here, along the way to Jaffna Peninsula, through the Mannar Island, this entire region has been identified to harbor moderate to excellent wind resource potential. So we have many operational and proposed wind energy projects in this region. And Sri Lanka has this ambitious target of producing 70% of its energy demands by renewable energy sources by 2030. So in line with these objectives, the government has gazetted specific energy development areas throughout Sri Lanka, and especially within this northern region, which has been found to harbor a lot of potential for the onshore wind energy production. So, yeah. So the problem associated with the wind farms, as Dr. Todd very clearly pointed out, so we can identify three main risks. So there's death through direct collision with the turbine blades and the towers, and there's this direct habitat loss, and also there's this indirect habitat loss or the displacement due to the disturbances caused by the wind farms and the associated structures, which we also call barrier effects. So what we are trying to assess here the effect of displacement on the waterbird population connectivity. Before moving on that, these are some examples to show that how the birds would alter their trajectory when they come across a wind turbine. Dr. Todd also clearly showed us how this happens, and this is based on observations from GPS tracking data. So this is not just us telling that the birds would just alter their trajectories. And these effects would be exacerbated when the wind farms are located in topographical bottlenecks. For example, Mannar. So Mannar Island, you can see it's a thin piece of land. It's 130 square kilometers in area. This connects mainland India to Sri Lanka. And we have, from our tracking data, we know that a lot of birds funnel through this piece of land. And the map here shows how the wind energy projects come in within this landscape. So shown in this green area at the two ends of the Mannar Island are the protected areas. The Adams Bridge National Park here, Wankalis Nature and Vegetative Nature Reserve. This is a Ramsar site. And this is the currently operating Tambapavani wind farm. This is a 100 megawatt wind farm, actually Sri Lanka's first large-scale wind farm. And then there's this another proposed project of it's a 50 megawatt wind farm with 21 turbines. And then we have this. This is the a project that created a very hot topic during the last 2 years. This is proposed by Adani Green Energy. It's a 250 megawatt big project with 52 wind turbines that are scattered across most of the Mannar Island. It covers the northern coast and then much of the center of the Mannar Island. So when this is the currently operational wind farm, if this too comes and if this construction happens, you know that almost the entire airspace would be obstructed by these multiple wind farms. So we know that there are a lot of studies, a lot of specific assessments has been and is being conducted targeting these specific projects. A lot of EIAs and avifaunal assessments, but none of the studies has aimed to address what the cumulative impacts of these multiple large-scale wind energy projects would be. So what, as a part of my PhD, I have one of my thesis chapters focus on this assessing how this cumulative effects are going to affect the population connectivity of the waterbirds in the region. So today, I'd like to bring your attention to this tool, which we call network analysis, and how it can be applicable in addressing this kind of conservation problems. So first, let's try to understand how we can look at this kind of a problem in a network perspective. Now, a conventional EIA would be done based on count data, right? So we'll go into a site, we'll count the number of birds in there, and then we'll simply assume that if there are 1,000 birds, this 1,000 birds is going to be affected by this project. And in the surrounding area, so there are many other habitats available supporting equal bird numbers or more. So we will simply assume, so even though if this 1,000 is gone, there are a lot of other habitats and a lot of other birds in the surrounding area. But it is not really, it's not happening in a real world scenario, because the birds are highly mobile species. They would be moving within and among the sites. So actually this footprint won't extend beyond this site if there is no connectivity at all. So as shown in A here, you can follow my cursor. But if it is located, suppose the impact would be on a peripheral site. So that means it doesn't have a lot of connections. It's in a periphery of the network. So then the impact would be larger. It would extend beyond the boundary of the particular site, but still it's not that it doesn't cover the entire network. But what if the site, the impact is on a very central site in the network? So the whole network would be impacted because of the connectivity. So we are trying to look at this wind energy problem, the issue of wind energy in this perspective, in a network perspective. So what we have done, the first step of our analysis is to construct and understand the existing connectivity network in the region. So which we have constructed based on the tracking data that we generated from tagging birds in Manna. So first, I identified the critical sites in this network, the network that we built for the Pork Bay Gulf of Mannar region. So based on the GPS activity hotspots of our tag birds. So likewise, these 16 sites is listed here. So you can see the sites that I highlight in blue are the most important sites for population connectivity in the network. So actually you can see these circles that have varying sizes. So the larger the size of the circle is higher the importance of this site, this individual site in the network, acting as, acting as critical connectors. So we have two metrics listed here, the degree and betweenness. So the degree is simply the number of other sites to which a particular site is connected to. So higher the degree, higher the connections with other sites. And betweenness is a measure of the measure of the bottleneck effect of a particular site. So it means how frequent a particular site would act as a bridge connecting two other sites. So higher the betweenness, higher the importance, higher the criticalness of that site for the entire network. So see, the sites in Mannar Island right here are such critical connectors. This number 11, 12, and 13 with 3 other sites here, here, and here. So this is how a network plot would look like. So this shows the same. So this was in the geographical space, but when we built when we build a network plot, this is how it would look like. This helps us to understand what are the critical sites in the network, what sites are the most central in the network. And here, the lines that connects this network, we call them edges. So they have varying thicknesses. So thicker an edge, thicker a line is, this particular two sites are heavily connected by the movements of birds. So here you can see the three sites in manner, number 11, 12, and 13 is clustered together. So that means they are locally very well connected, and it's also within the center of the network. So a lot of other sites have been positioned around it. So it has a lot of sites, connected to those three sites in manner. Right. So having understood this, so we as the second step of the analysis, we came up with several constraint network scenarios by simulating different scenarios where we removed specific nodes, specific sites from the network, and we tried to look at the effect of it on the entire network. Now, for example, so for this simulation, we considered the energy development areas in the region. So if an energy development area is overlapped with a particular site, so we assume that these sites would be inaccessible for the birds due to these barrier effects. And then as a result, we removed that particular site from the network and built and constrained network scenario. So we had four scenarios constructed, starting from a conservative assumption to a worst case scenario, where a certain percentage of overlap with an EDA of a site would make the site inaccessible to birds. So if there's any overlap with an EDA, the site is removed from the network, assuming it's inaccessible. So I'm not going to go into detail with all the scenarios that I simulated, but bring your attention to the worst case scenario. So here we have removed these three sites in manner 11, 12, and 13, assuming that it would be inaccessible due to these multiple wind energy projects. If something happens, like the map that I showed you in earlier, so the Mannar Island wetlands are there no more. What happens to this connectivity network? Right. So this is the existing network, and this is the constrained network that was a result of removing these three critical sites. So you can see now the complexity of the network has simply dropped. You can see some of the sites have been isolated, and the edge density, the density of the edges has been reduced. And to quantify actually, so this is how it looks visually. And if we quantify the effects, so we have the site level metrics. So that means the importance of a particular site to maintain the connectivity of the network. And the site level metrics, we found that it is dropped. And there was a significant drop in the site level metrics. And we saw that even though these direct connections dropped and fragmented local movement routes, we saw that the betweenness increased. Even though this effect is insignificant, there's an ecological relevance in this, so I want to highlight that as well. Betweenness is increased as a result because the critical sites are lost. The remaining sites will now act as bridges to connect the remaining sites, so increase their bottleneck effect. So the betweenness increase. So that means this imposed extra pressure on these remaining sites. So if something happens, if some effect is going to be there on these remaining sites, there would be more effects on the remaining network as well. So these are how the site level metrics was affected as a result of removing these nodes or removing these sites. And this is how the whole network or the overall network was affected. So 3 different metrics we have measured: edge density, clustering coefficient, and centralization. We saw that there's a significant drop in clustering coefficient especially. So that means the remaining nodes in the network won't no longer form effective clusters. So the movement network is deteriorated. So this is a summary of different networks that I built. I didn't want to go into all the details here, but what I want to highlight from here is, as more critical sites in the network were lost, the severity of the effect at site level and also at the network level were increasing. So what I want to highlight from the talk today, or the take-home message, is the importance of incorporating population connectivity as a critical factor into environmental impact assessments and strategic environmental assessments in developing renewable or the wind energy in a sustainable manner. So we have to go forward from just assessing the wind energy effects rather than based solely on count-based data, but try to look at these problems in a more broader, a network or ecologically connected sites as a whole, and to understand the real effect on the population, on by wind energy. So this would make the wind energy really green, not gray. So that's the end of my presentation. So if you have any questions, you can direct me. I know it's kind of technical, but I'll try my best to answer any of your questions. Thank you very much.
Thank you, Jayamini, for another wonderful presentation. It was a bit scary because there are, as you know, there are wind turbines, offshore wind turbines are planned in Indian side of Mannar. Hopefully, you are, tracking data and other, scientific information would help the, policymakers to, or conservationists to, make this offshore energy more, sustainable and less, negative impact to the birds. Thanks again, Gayomini. So probably you can stop sharing the screen, Gayomini.
Sure.
Yep. Yeah. If you have any questions to Gayomini, please, again, type it on the chat box. Let's welcome our next presenter, Alyona Kaptinkina, sorry for the pronunciation. Alyona is a researcher at the Institute of Zoology, Kazakhstan, and for the last 3 years, she has also been working with Biodiversity Research Center, Conservation Research Center in Astana. Her research focuses on study and conservation of rare raptor species in Kazakhstan, with particular attention to the steppe eagle, Egyptian vulture, cinereous vulture, saké falcon. She has also been contributing to the assessment of the potential impacts of renewable energy development on the raptor populations in Kazakhstan. Over to you, Alyona. Do you want me to share the presentation for you?
Hello, dear colleagues. Can you hear me?
Yes,
Yeah?
yes.
Yeah, please help me with presentation. It will be better.
Sure. Definitely. Yeah. Is it
Okay,
visible?
I understand. Yeah, it's good. Hello, everyone. I'm very glad to be here. Thank you for inviting me. It's a great honor for me to give a presentation today. Thank you very much. I hope that what I will share today will be useful and kind of interesting for you. My topic is green energy and birds of prey in Kazakhstan. Next slide, please. And today I will, I will try to be short because it's the last presentation and everyone maybe it's a little bit tired. I will explain about wind energy in Kazakhstan, problems in Kazakhstan with wind energy industry, the golden eagle in Karatau and Chuli Mountains, and how to minimize damage and solve the problem. Next slide, please. Everyone knows that a number of wind and solar power plants is now actively increasing all over the world. And especially in the countries of our region, in Central Asian countries. At the same time, wind energy is also developing rapidly in Kazakhstan. Currently, there are 59 wind power plants in Kazakhstan, including two especially dangerous for birds, built in the Karatau Mountains along the western circumhimalayan migratory corridor of the Central Asia. It's Zhanatas and Chokpar, Shokpar wind farms, and wind power plant in the Chuli mountain near the village of Mirny is a design stage now, the capacity of which will be 50% of total volume of all renewable energy facilities in Kazakhstan by 2023. And also Abu Dhabi Future Energy Company, Masdar, and the Ministry of Energy of Kazakhstan signed the agreement to build 1 gigawatt wind farm project in Karatau in Jambil region. And cumulative impact of these wind farms on the raptors population is still unknown. It may be harmful with future development of the wind farm network in Karatau and Chuli Mountains if it happens before in the same way as in the Zhanatas and Shokpar wind farms, the design of which completely ignores the risk of rare species. The share of wind energy in the country's energy balance will only grow. We know it, which means new wind farms will build in the migratory corridors, also likely killing more and more birds, unfortunately. Yeah, next slide, please. As I said before, we have two dangerous wind farms, dangerous for birds, wind farms in Kazakhstan, in Zhanatas and Chokpar. Now I would like to explain a little bit more about Zhanatas wind farm because it's a really long story already. We are trying to work with farm for 3 years, but unfortunately almost nothing changed. Next slide, please. Here on the slide you can see the Zhanatas wind farm and Shokpar also. It's red square. Maybe it's not really clear, but you can see red square on the maps and data from article of ornithologists from Institute of Zoology of Republic of Kazakhstan. And you can clearly see the migration corridors in Kazakhstan, and you can see where is wind farms is located on migration corridors. Preliminary bird surveys for the plant Zhanatas wind farm were completely falsified. This is indicated by comparison of the data in the project documentation with available published information and our data, our observations from our team. And now I've explained why it's happened before construction began, the project site has nesting areas for the golden eagle, two active nests for short-toed snake eagle, one active nest, Eurasian eagle owl, one nest, Egyptian vulture, one nest, and black stork. And also the plateau was a stopover for great bastards with over 50 individuals. Next slide, please. Intense migration of raptors occurred across the plateau near the village of Janatas during both the spring and autumn period. Many of you maybe know about Karatao Mountains and that it's a really important area for migration in Kazakhstan. We also have only one in our region, very old ringing station. It's called Chakpak, and unfortunately also one wind farm will be very soon built there, but I will not tell about it today. I will explain about Janatas. And information about bird migration through the project area was confirmed by both visual observations in 2010, which did our colleagues, and the tracking of imperial eagles, steppe eagles, and greater spotted eagles from Altai-Sayan region. It's region in Russia and project of our Russian colleagues from RRCN, as well as steppe eagles from Central Asia. It's also project of SCBK and RRCN project. This information was particularly published in online databases such as eBird, iNaturalist, Faunistica, and BIF. These tracks of imperial, greater spotted, and steppe eagles are available on public internet resources and were particularly published before the implementation of Janatas wind farm project. It means that all data was published before. Before Janatas wind farm was built, and it means that all data was ignored. According to the result of studies conducted in 2002-2003 by our team, breeding has stopped in all nesting areas of rare species mentioned above around Janatas wind farm project site. The area has also lost its value as stopover for great bastards. Also, bastard continue exposing them to risk of collision. And we have repeatedly sent letters to these organizations to inform the owners of the wind farm about the importance of preserving biodiversity. We tried to explain that rules of constructing the wind farms were broken. We offered option to minimize the negative impact on biodiversity and offered our help. Unfortunately, the management of these wind farms refused to make contact, cooperate, or in any way solve these problems. Next slide, please. After several attempts, our organization filed a complaint with the European Bank for Reconstruction and Development, EBRD, the bank that financed the construction of this enterprise. Our complaint is currently are in review. We had also a Zoom meeting, we had a long discussion, and now we are just waiting. It doesn't mean that we finished with it. We are planning to continue. We want to save birds there, and we will see what will happen next. And next slide, please. Yes. Why we are working in the Karatao and Chuili Mountains? The Karatao and Chuili Mountains play a critical, important role in bird migration in Central Asia. Located along the key migratory corridor, they provide essential stopovers for millions of birds, not only raptors, for many other species also, to rest and refuel, as they cover very long distance. Next slide, please. We recently published a new article dedicated to the study of the golden eagle in this area. It's called Golden Eagle in Karatau and Chuily Mountains, Kazakhstan, and assessment of risk to its population from developing wind energy. And my story now will focus on this species because we have a lot of data we have something to share. The golden eagle is the largest of breeding eagles of Kazakhstan, listed in the Red Data Book of Kazakhstan as rare bird with declining population number. And here on the slide, you can see the numbers. The golden eagle population in Karatau as of 2024 is estimated on average 466 breeding pairs and an average of 1,209 individuals. It's with juveniles and subadult birds. In Chuily Mountains, it's average 222 breeding pairs and 575 individuals. The number of golden eagle migrating for Karatau is estimated at average 8,386 individuals, and you can see the big number. And yes, birds not only breeding there, so many birds from other regions are migrating here. That's why it's a really important corridor, but not only for golden eagle, for other eagles also. Next slide, please. Several studies indicated that golden eagle several studies indicated that golden eagle is really vulnerable bird to wind energy development. This large eagle firstly dies as a result of collision with the blades of wind turbines of the wind power station. And secondly, they leave habitats on which the turbines are built. In 2022, we monitored known golden eagle breeding territories in Karatau, and 2023-2024 in Chuily Mountains. We also checked previously and visited areas to clarify the details of the species distribution and its abundance. And in the zone of influence of the Janatas and Shokpar wind farm, which has a radius of 4.5 kilometers, 3 pairs of breeding golden eagles disappeared after 3 years. And some birds from the broken up pairs died after hitting the wind turbines blades. We found the remains of 2 golden eagles under the turbines, which confirms this. And also, in addition, you can see the photos from our field trips. In addition, the carcasses of other bird species such as steppe eagles, cinereous vultures, and long-legged buzzards were found under the turbines in 2024. And unfortunately, we have new data from 2025 already. This year, golden eagle and cinereous vulture were also found dead under turbine, which is located 1 kilometer from an active golden eagle nest. Yeah, very, very close to wind farm. Based on calculations on the CRM band, a risk map with a cell step of 5 kilometers was created, representing an assessment of the probable mortality of eagle during the construction of wind farms in these cells. We published it in our article, which I mentioned before. All data and methods you can find there. The result of this study apply to the conservation planning efforts of the Golden Eagle, analyzing the risk of developing not only wind energy, but also other land uses, such as including mining and even recreation, and implementing compensatory measures for human intervention in the Golden Eagle habitat. Yes, and next slide, please. In the article, we describe recommendations of how to minimize the risk of Golden Eagle death. Here are some points of those points. At the entire complex of turbines of the Janatas wind farm and the Shokpar wind farm, according to modeling which we did in the CMR band, 17 eagles per year may die. Yeah. And to minimize the risk of eagle collision with wind power plant turbines and preserve the golden eagle breeding population, a zone with radius 4.5 kilometers around golden eagle nest should completely exclude the presence of wind power plant turbines. And in a zone with a radius of 12.8 kilometers, management of the placement and cooperation of wind power plant turbines should be provided that excludes harm to golden eagle. And next slide, please. Now I want to share our work. It's BioDiff program, which our team is working for. Our team has created a program that allows for a complete cycle of processing field data from bird observation and tracks, from importing into the system to finishing the modeling and getting population estimates. This data is used to calculate the probability of collisions with wind turbines. Any researchers can register in the program, process their data, and submit it for consideration to be integrated into the risk map. Any project developer can enter their wind farm data to access the risk and export the information for their use in their local GIS. And this website is not finished yet, because it's actually really difficult and long-term work. We are still working on it. When we will finish, I will try to share it in our email list. And the main idea was that, and our hope also, that people from different spheres, like from energy companies, like managers, researchers, and people from government will use this website to check data which we and our colleagues already have, which already updated, and use it for future wind farms. Yes, and I would like to conclude a little bit. To achieve global climate change mitigation goals, it's essential to promote sustainable wind energy development. However, it's important to recognize that wind energy, like any energy sector, can affect rare and protected species. To avoid increasing the conflict between human and the environment, all possible negative consequences of wild energy development must be identified early, assessed, and effectively prevented or mitigated. The golden eagle is a national species of Kazakhstan, and it's at risk from wind energy now. When developing the wind power plants network, special attention should be paid to its protection, especially in area where its large breeding groups are concentrated, such in Karatau and Chuili Mountains. And this is not only about golden eagle, it's about other species also. The result of this study are applicable for conservation planning efforts for golden eagle, analyzing the risk of developing not only wind energy but also other land uses, including mining and even recreation, and implementing compensatory measures for human intervention in the golden eagle's habitat. We suggest that investors and managers, when designing wind farms in Karatau and Chuili Mountains, will check the map of risk of collisions between golden eagle and wind turbines, which we also published, and take into account the buffer zone around the eagle nest that we proposed. And that's all. Thank you for next slide, please, also. Yeah, and thank you for your attention. Yeah, if you have questions, I can answer.
Thank you, Eliana, for the wonderful presentation and taking us to Kazakhstan. Yeah, thank you very much. I once again thank all the three speakers for the wonderful presentation today. Let's move on to the question and answer session. I see there are a lot of questions. Let's start with Dr. Todd. I guess this is the first question from Tej. Dr. Kurtzner, excellent presentation, greatly appreciated. A few questions. Did the avoidance of tower only by 500 meter make a significant difference when there are multiple turbine in the modeling you showed us? Curious how the single black color of the blade affects the bats. Are they able to detect these at night?
Yeah, thank you, Raj. Those are great questions. With regard to the first question, the moving the turbines 500 meters, that was a modeling study, and unfortunately, we to our knowledge, it has not been implemented in the field. So we don't know if it was consequential, it has not been tested in the field. The question about the black blade and the bats is an interesting one. Most of the time when we think about bats, we think about them using echolocation to navigate. But it turns out that especially when in the United States, most of the fatalities of bats are during the migration season. And during migration, bats use vision to migrate. And so we don't know if this will impact bats, but we realize that it's important that we consider this possibility. And so in this study, we are monitoring for bats as well as for birds, because if it makes a difference, it would be important to know.
Great, thank you. Thank you, Kursner. And there is the next question from Sagnik Ghosh. This talk was really informative. I would like to understand, how do we decide which species to save from wind turbines in terms of avoidance, etc.? Are these apex predators like golden eagle due to their possibly keystone status? Additionally, does the protection of one species create an umbrella effect of protection for other birds as well?
Yeah, I think that's also a really good question. You know, at the U.S. Geological Survey, I mentioned we have fundamental science principles that guide how we do research. And one of the things that we are told is that we are not allowed to have opinions about policy, right? We are only allowed to comment on the science. And so really, when we think about protecting which species to protect, there are reasons probably in three categories. There are scientific reasons or conservation reasons. well, science and conservation are sort of different. There are the conservation reasons are the ones that you describe. If one species can serve as an umbrella, if we protect golden eagles, we may protect other species that have similar soaring behavior, that have similar flight behavior. There could be some scientific reasons, but I think for the most part, science is agnostic to this. Extinction is part of science, and I'm not sure there are good scientific reasons to protect one species versus another. And remember, if we save golden eagles, we might have negative consequences for bats. Or if we save bats, we might have negative consequences for golden eagles. And which ones we want and which species we want, those are really social and political decisions. And those are really important decisions. But at least from the perspective of the science that I do, those are not decisions for me to make. Those are decisions for managers and policymakers. And I think there are good reasons to protect some species and not others. In Kazakhstan, golden eagles are the national bird. And so there's a lot of interest in protecting them. In North America, in the US, we have laws that protect certain species and don't protect other species. And those are all reasons how those decisions get made. But from many perspectives, those are really important. They're social, they're political, sometimes conservation. They can be informed by science, but very, very rarely are they scientific decisions.
Thank you, Dr. Todd. There is a couple of questions. I think this is last one for Todd. Are the power lines associated with the turbines overhead, or they are buried underground? If they are overhead, did you consider the bird mortalities associated with such power lines as well? Yeah.
Also a really good question. So I think that in the slides, I very quickly mentioned infrastructure associated with wind turbines. And this infrastructure is really important. If it is above ground, bird mortalities, birds can collide with the power lines. They can also, if they're big birds, they can be electrocuted or have other consequences. In the paper, we discuss that in detail. We mentioned some of these impacts. It is a really important thing, and it's not just the power lines, but it's also the roads that are required. It's the fences that are required. It's the human visitation that's required. All of these things are associated with the wind facility, but they're not the wind turbines. Those are really important. So in the US, most of the power lines are above ground. A small number are below ground. Remember, there's also substations and places where all the lines come together, and those can be dangerous for birds as well. But even burying the power lines has consequence for biodiversity, right? It's going to destroy a lot of the earth and change the landscape. Different than an above ground power line, but still relevant.
Thank you, Dr. Todd. And I think that was the last question for you. And there are a couple of questions for Gayomini. I think there are a lot of congratulations for Gayomini for the presentations. And there is one question from Devesh Gadvi. Did you also evaluate the impact of power lines associated with associated infrastructures of windmill? I assume more than the turbine power. I think the same question. Power lines are responsible for high mortality. I believe you answered this question, but if you want to, go ahead and elaborate, okay.
Oh, yeah, sure, Dr. Ramesh. I answered the question already. Yeah, I actually didn't specifically focus on power lines, but rather looked at the wind power facility as a whole and assumed that in my analysis, so I assumed a worst case scenario where, due to the construction of this facility, especially the wind turbines and the associated structures, the nearby or the overlapping wetlands becoming inaccessible due to barrier effect. So that only I considered in this analysis, but I didn't looked at how the empirical data or the collision data on the turbines or the power lines for this analysis. But this is rather a predictive model that we did to understand the cumulative effects of multiple wind energy projects on the waterbird population connectivity. Not specific effects. I didn't evaluate any specific effects of any specific projects.
Thank you, Gaimini. And there is one comment from Fanjuan Meng. Well done, Gaimini. Congratulations for the presentations. Thanks to you and Professor team for dedicated fieldwork on CAF. I think it's all you're appreciating your presentation.
She's one of our collaborators.
Okay, well, yeah. I think that's it for Gayomini's presentation. And for Alyona, there is a question from Anand Chaudhary. Thank you, Alyona, for the presentation. Very insightful. You mentioned land birds, smaller birds as casualty of wind energy. Can you provide us more information on how the wind farms in places like this, like the Xantas area?
Sorry. Okay, I should check the question. Yeah.
You didn't get the question. So the question is,
Yeah,
you
I
mentioned.
found it. Yeah, thank you.
Okay.
About smaller and other species of birds that they're migrating there, and we know it, and we also know that so many small birds are dying on Janatas wind farm, but unfortunately we can't do the proper survey there because it's private territory, and we're not allowed to be there anytime which we want. But we know we can see from quite far away that many other birds are dying there, and so many, for example, raptors coming there to eat small birds, and so many jackals and dogs around with turbines now because so many small dead birds, and we don't have data of how many birds died of land birds, smaller birds, and so that's why I can't say a statistic about it, but we know that birds are also dying there. Yeah, thank you.
Thank you, Alyona. And I believe that was the one question for you. And if I may, I have one question for you. The sensitivity mapping tool you have shown. There are 3 species so far. I think you are incorporating. Are there any plans to incorporate more species into the sensitivity mapping tool? Or like when it is likely to be it can be publicly available? You said it's under construction.
Yeah, thank you for the question. It was just the example. Now we are working on more species, not 3, around 6 species, I think. It depends on special modeling which we are doing. Yes, it's we are trying to add new data from our research, and yeah, it will be more species in the end.
Yeah.
Thank you.
And I think the same question from Devesh is the power lines in the area in Kazakhstan are buried, or it's overhead line, or have you found any carcasses under such power lines?
It's related to wind farm or general power lines, like
It's power line associated with wind turbines. I think that's what the wish is.
Yeah, power lines also is a big problem for Kazakhstan. We are trying to work on it. Yeah, as I said in private messages, I can share our latest articles about it. But yeah, we're also working, we're doing research, and yeah, unfortunately, so many birds also dying on power lines in Kazakhstan.
Okay. There is one more question from Jeremy. Have your tracking data of raptors shown any change of behavior around wind turbines?
Yes, we are studying different species of raptors in Kazakhstan. Like as we are working mostly on Karatau and Chuili mountains. We are tracking Egyptian vultures, cinereous vultures, steppe eagles, imperial eagles, and yes, we have data, and we also using our colleagues' data, like data which were published 10, 20 years ago. And yeah, we can see how birds are migrating there. Thank you.
Thank you. Todd, your hand is raised. Please go ahead. Yeah.
Yeah, I wanted to add to that. We also have a lot of tracking data. The problem is that when you see a track that goes near to wind turbines, it's very difficult to know if the bird is responding to the wind turbine or to something else. And so we have, like Aliona, we have these data, but it's very difficult to understand. And really, it's a rare event when a bird comes close to a wind turbine, and it would be important to have hundreds of these. And really, it would be best to have data from before the wind turbines were present and then after. It is a very, very difficult data set to interpret without a lot of repetition.
Thank you. And there was, I think, a couple of questions you have already answered. I thought there was one question from Kaman and from Tej. Would you like to add more?
I answered in the chat. The question was about the importance of bats and wind turbines, and it is something that is of growing importance. I think that as people have used dogs, we begin to find more and more bats and also small birds, also passerines, because those are removed very quickly by scavengers. And so when you start to use dogs and you search regularly, you find things that you didn't know existed. There's a lot of citations in our paper on this, and that might be a really good starting point for people. But I'm also very happy to answer emails if people want to ask questions.
Thank you. Thank you. I think there are a couple of more questions. Probably we will take one last question and we'll hand over the session to Catherine to end the webinar. So it's question to Aliona from Anand Chowdhury. Chopper looks like it is in the migratory route of birds from the Lee River Delta, Lake Balkash. Is that correct? That was the question.
Yeah, I can see the question. Thank you. And yeah, it's a migratory corridor, and birds from this corridor is coming through different routes there. Maybe you saw it on my presentation map. And yes, it's like birds which are breeding on Balkhash Lake or River Delta, and they're coming through Chuili mountain immigration corridor, and some of them through Karatau.
Thank you. Thank you, Aliona. Once again, I thank all the speakers and all the participants for participating. Now I hand over to Catherine to end this event. Catherine, over to you.
Thank you so much. I think I am once again echoing the many comments in the chat that we're congratulating all of our speakers and thank you really once again. There was some very sobering data and case studies that were presented, and of course, as we will continue to see into the future, considerations of green energy and conservation will really only grow. So we were very lucky to have tonight these really interesting presentations from these three speakers who presented not only new considerations, but also new methodologies, and also very interestingly, new ways of how we might actually engage with policymakers or energy companies or other stakeholders to actually influence some of those policy decisions. And when I was also listening to these presentations, it kind of just gives me more motivation to work again and to continue working within the Central Asian Conservation Network and really to provide this strong platform, not only to connect researchers and conservation practitioners along the flyway, but really to provide this platform for integrated flyway level research so that we might understand what is happening in Mannar Island in Sri Lanka, how this might affect bird populations in Kazakhstan and vice versa, and in the other countries along the CAF. So thank you really everyone for joining us again. I'll just say a few very brief words on the way forward. So from our end, the work of the Central Asian Conservation Network Green Energy and Conservation Working Group will continue. And under the guidance of Ramesh, the group has developed a very strong strategy concept, and a first priority is to continue the development of the digital hub, which will house this centralized collision and risk database for the CAF. In parallel, we are also looking for funding opportunities to initiate further research and monitoring in key collision hotspots and data deficient areas, and also to enhance the transboundary cooperation on the topic. We're also aiming to improve technical capacity along the flyway through organising regular workshops such as these and training sessions on monitoring, mitigation and planning practices. And we will also be engaging with the CMS Energy Task Force to ensure coordination and to develop on any synergies. So importantly, we really see the role of this group as that to support strengthened engagement with governments and donors in order to lead the integration of bird-sensitive planning and social justice considerations in renewable energy developments. So thank you once again for your participation, and I would also like to mention once again the support of the Ornithological Society of the Middle East, and thank you to them for providing the funding for supporting this webinar series. Okay, well with that, I would wish you all a very good evening, and thank you once again for joining, and we will be sharing the recording of this webinar with you in several days' time. Thank you once again. Good evening.
Thank you.
Thank you. Bye-bye. Yes.